In this video, I will show you how to find the value of a trig function given a point on the terminal side of an angle. So this concept is all about right triangles. So I'm going to draw a sketch of what we have here. So the point 18, 20 is on the terminal side of some angle. So let's see, 18, 20, let's say that point is right here. Alright, so we're talking about an angle that passes through that point. Now, let's talk about right triangles. I could make a right triangle out of this. Okay, now I have my reference angle right here. I can find the tangent, sine, cosine, whatever, if I know the sides of this triangle. So 18 is the x value, which means that this side of the triangle has a length of 18. This 20 is the y value, which means this point is up 20. So actually this happens to be enough information to answer this particular question, but very often we have to do the Pythagorean Theorem and find the hypotenuse as well. But this time we don't have to, because this is enough information to know what the tangent is. So you know the tangent of theta is opposite over adjacent. So that would be 20 over 18. And I just feel like we should just reduce that. Right? So this would be 10 over 9. And the cotangent is the reciprocal of tangent. So if the tangent is 10 over 9, then the cotangent should be 9 over 10. Okay, so that was a relatively easy version of what we're doing. Let's go again. So here we have negative 17 comma negative 17. Let's draw a sketch of that. Alright, so here's the point negative 17 comma negative 17. So we're talking about an angle that goes through that point. Now, what we care about most of all is the reference angle. So the angle that I just drew, it almost doesn't matter what it is, but the reference angle is going to be 45 degrees. Okay? I know that because look at this thing, man. We have negative 17 and negative 17. So if I draw a right triangle forming that reference angle, then the x value of negative 17 means that this side of the triangle has a length of 17. And I'll call it negative 17 because it's to the left. And this is 17 down. So this side of the triangle has also a length of 17. This is an isosceles triangle, so you know it's got to be a 45, 45, 90 triangle. Okay, so that makes my life easy because I've memorized the pattern of a 45, 45 triangle. It goes leg, leg, and then leg radical 2. So this should be 17 radical 2, all right, in length. All right, always positive for the hypotenuse here. Okay, now, the secant is a reciprocal trig function. So let's start by looking at the regular trig function. So secant is the reciprocal of cosine. So let's start by asking ourselves, what's the cosine of theta? Well, cosine is adjacent over hypotenuse. Okay, so it's going to be negative 17 over 17 radical 2. So negative 17, that's adjacent, over 17 radical 2, the hypotenuse. Okay, now let's just simplify this a bit. So these 17s are going to cancel each other out. So it's going to be negative 1 over radical 2. All right, so fine, that's the cosine of the angle. So what is the secant? Well, the secant is going to just be the reciprocal of this. So in that case, the secant is going to be negative radical 2. I just did the reciprocal of this guy. So that should be the final answer for number 20. Okay, so the point on the terminal side is negative 8 comma negative 2. So that's another one that's in the third quadrant over here. All right, so here's the point negative 8 comma negative 2. So if I make a triangle out of this, a right triangle, you know, sort of forming up the reference angle right here. The negative 8, this x value, tells me that this side of the triangle has length 8. Since it is to the left, I'm going to go ahead and keep the negative sign. That'll help me keep track of the sign of my answer. This y value is negative 2. That means this side of the triangle has length 2. And again, I'll go ahead and just call it negative 2 because it's down. Okay, now we are going to need to know what the hypotenuse is because the sine function involves the hypotenuse. So for that, we're going to do the Pythagorean Theorem. So leg squared plus leg squared equals hypotenuse squared. Ignore the signs when you do this part. So the hypotenuse squared is going to equal to 2 squared plus 8 squared. So the hypotenuse squared is equal to 4 plus 64. So hypotenuse squared is equal to 68. So the hypotenuse is going to be the square root of 68. Let's see if I can simplify this. Well, 68 is divisible by 4. So let's see. So this is going to be the same thing as 4 times 17. So I can go ahead and take the square root of 4 and get 2 radical 17 for the hypotenuse. Okay, so the hypotenuse is 2 radical 17. Okay, so now sine is opposite over hypotenuse. So that's going to be negative 2 over 2 radical 17. So these 2's are going to cancel each other out. So for your final answer, you're going to have negative 1 over radical 17. And you could rationalize the denominator and make radical 17 over 17, but this is good enough for me. Okay, one more. Okay, so this is going to be in the second quadrant, so let's go ahead and draw our sketch. Okay, so this will be the point negative radical 19 comma 9. And let's make a triangle out of it. Okay, so this is the angle going through here. Let's make a triangle out of this thing. Okay, sort of showing the reference angle. The x value represents this side of the triangle. The y value is the height of the triangle, so we have this. Now cosine involves the hypotenuse, so we need to figure out what the hypotenuse is. So let's go ahead and use the Pythagorean Theorem. So when I do this part, I'm going to ignore the signs. So the hypotenuse squared is going to equal to leg squared plus leg squared. So that's 81 plus 19. Okay, so the hypotenuse squared is equal to 100. So the hypotenuse is 10 when you take the square root. Alright, so the hypotenuse is 10. So now we are ready to answer the question. So what is the cosine going to be? Cosine is adjacent over hypotenuse. So that'll be negative radical 19 over 10. So that's it for number 22. And that is going to be it for this video. In the next video, we're going to find the value of various trig functions given a diagram. So if that's something that you want to learn about, I will see you on the next video.